Okay, so in these three problems, we're going to be solving three rational equations. And the way we're going to solve these rational equations is to use these steps. First thing you're going to do is you're going to find the least common denominator, and then you're going to find any restrictions. Second thing you're going to do is once you find the least common denominator, you're going to multiply both sides by that least common denominator. And then you're going to remove any grouping symbols, combine like terms if you can, etc., reduce, and so forth. And then you're going to solve the resulting equation, and then you're going to check for any extraneous solutions. And you're going to do that, you're going to check for extraneous solutions by technically just looking at these restrictions. See if any of these proposed solutions is a restriction. Okay, so let's look at number one. So here's number one. And so we have this rational equation, and notice you have an equation that has rational expressions, and in this case, the denominator has variables in it. Notice, though, that in all these three denominators, you have monomial factors, so that's going to be the easy kind, where the monomial factors are easy to deal with. So if I'm going to find the least common denominator, one thing I'm going to look at is the coefficients. The coefficient here is 6, the coefficient here is 2, and the coefficient here is 6. So the least common denominator of 6, 2, and 6, or the least common multiple of 6, 2, and 6 is 6. And then in terms of the variable factors, I have two factors of x, one factor of x, and two factors of x. So my least common denominator must include the largest number of factors of x in a denominator. So that would be 2. So 2 factors of x. So I found the least common denominator. And before you go on to the next step, you got to make sure you determine what the restrictions are. And you're going to have restrictions for the most part whenever you have variables in the denominator. And so basically you got to ask yourself, you got to remember that when you have a rational expression, you can never divide by 0. So you got to determine what makes this denominator that I'm circling equal to 0. Same thing here. You got to do all of your denominators. What makes this denominator equal to 0? What value of x makes that denominator equal to 0? And what value of x makes this denominator equal to 0? So if you look at 6x squared, for example, I'm going to go ahead and just write it right here. So remember, you want to determine 6 times what number squared is equal to 0. Now that's really the easy kind because you know that if I take the value of x to be 0, 0 right here, so look, you get 6 times 0 squared. So if x is 0, 0 times 0 is 0, and 0 times 6 is 0. So that's the only value of x that will make this denominator equal 0. So right now I know that one of my restrictions is that x cannot equal 0. But you got to look at all the other denominators as well. Well, this one here is the same as this one, so we're done with this one. And this one is as easy as well, right? So 2x, where's 2x equal to 0? Well, 2x is equal to 0 when x is 0. That's when 2x is equal to 0. So x equal 0 is the only restriction. So now once you find the least common denominator and once you find your restrictions, the next step is to multiply both sides by that least common denominator. And notice on the left-hand side, you only have one rational expression, and on this side you have two. So the way we're going to do this is that since there's just one rational expression here, I'm just going to write it like this. You're going to take the least common denominator, you multiply by both sides. What you do to one side, you do to the other. So 6x squared times 1 divided by 6x squared equal. Now, I have on this side two rational expressions, so I need to put that in parentheses or in brackets, whatever you want to use. So I'm putting this right-hand side in brackets. But I got to also multiply by 6x squared. What you do to one side, you do to the other. So remember, that's the least common denominator. All right, now, the next step is to remove grouping symbols, reduce, combine like terms if possible. So I'm going to go ahead and remove this grouping symbol, and at some point I'm also going to reduce what I can. But you got to remove the grouping symbol first in this case. So I get, I'm just going to rewrite the left-hand side equal, and then we're going to distribute the 6x squared. So 6x squared times 1 divided by 2x plus 6x squared times 7 divided by 6x squared. All right, now I'm going to reduce. So notice that the 6x squared that's in the denominator, the factor of 6 divides out, right? And then the factors of x squareds divide out. And over here, this factor of 2 will divide out into this factor of 6. So 2 into 2 is 1, 2 into 6 is 3. Now I only have one factor of x here and I have 2 here, so I can divide out all of this factor of x here into one of these, and you're left with one factor of x. Over here, same thing as this one. So all of these will divide out into these. All right, now what I have now is 1 times 1 times 1, which is 1, equal 3, don't forget that's an x right here, 3 times x times 1, which is 3x, plus, that's a 1 times 7, which is 7. So notice I went from a rational equation to a linear equation. And notice that this linear equation does not have any fractions. That's the whole idea. So as we go through this process, notice the reason you're multiplying both sides by the least common denominator is to clear these denominators. So you want factors of 1. So you want this to be a 1, this to be a 1, this to be a 1. And notice when I did that, I have 1 in the denominator, 1 in the denominator, 1 in the denominator. So that's a whole reason for clearing the fractions to get a resulting equation without any fractions. And to do that, you got to make sure you have 1's resulting as factors in the denominator. Now, this is an easy problem to deal with. It's a linear equation, so that's easy to deal with. You bring all the constants to one side, variables to the other. So I'm going to subtract 7 from both sides. And when I subtract 7 from both sides, I get 1 minus 7 is a negative 6 equal, this is 0, and I get 3x. And then if I divide both sides by 3, I get my proposed solution to be a negative 2. Now I'm using the word proposed. So that's my proposed solution because this may not be a solution to the original problem. So I want you to notice that this proposed solution is a solution to this linear equation. But this linear equation is not the same as this rational equation. They're different. This has variables in the denominator. But this proposed solution, there is a possibility it could be a solution to the original as long as it's not a restriction. So if I'm doing all this work correct and I get this proposed solution, all I have to do is check to see if it's a restriction. If it's not a restriction, then I'm good. It's a solution to the original. And so notice that the only restriction is that x cannot equal 0. So my proposed solution is a solution, is the actual solution. So x equal negative 2 is a solution. All right, so it's not an extraneous solution. So an extraneous solution, some authors or teachers will refer to this as false solutions. False. So meaning that it's a solution to one of the resulting equations, but it's not a solution to the original. Okay? All right, so that's all you do. So that's your proposed. Before you say it's a solution, you better check that proposed solution against the restriction. All right, so that's number 1. All right, let's look at number 2. So number 2, let's suppose in number 2 we have this situation. We have this problem, number 2. So we have 1 divided by m squared minus m plus 1 divided by m equal 5 divided by m squared minus m. Okay, now the first thing you have to do is find the least common denominator. Now before you find the least common denominator, you got to factor any denominators if you can. Notice that I can factor this the denominator here and this as well. All right. So and this is monomial factors, so I can't do anything with that. But I can factor m squared minus m. So the first thing you're going to do is you're going to factor this. So I'm going to rewrite this as 1 divided by m times m minus 1. So I factor out in m. The GCF here is m. Plus 1 divided by m equal 5 divided by m times m minus 1. Now, remember the approach is once you find the least common denominator, you can multiply both sides by that least common denominator. Don't rearrange anything here. Don't bring this term over because the denominators are the same and this term the other side. That's not the approach that you're asked to do here. The approach is Once you find the least common denominator, you multiply both sides by. All right, so let's find the least common denominator. So remember, the least common denominator must include every distinct factor that you see. So you have to look at all your denominators. So my first factor C is an m. I have to put that in my least common denominator. My next factor I see is m minus 1. I have to use it. My next factor I see is an m. I already have it. The next factor I see is an m. I already have it. And the next factor I see is m minus 1. I already have it. So there's your least common denominator. Now, once you do that, remember, you got to find your restrictions. So you got to ask yourself, and this is m here. So you got to ask yourself, what value of m will make this denominator 0? And all you do is just look at the different factors. So my first factor I see is m. So just think about this. Write your factor and say equals 0. Well, m's equal to 0 when m is 0, right? So one of my restrictions is that m cannot equal 0, because look, if m is 0, 0, now look, 0 minus 1 is a negative 1, but 0 times a negative 1 is still 0, right? So you're dividing by 0, so m cannot be 0. Now look at your next factor, m minus 1. So ask yourself, where's that equal to 0? Well, if I add 1 to both sides, I find that m is equal to 1. So when m is equal to 1, notice what happens. 1 minus 1 is 0. So 1 times 0 is 0, and I'm dividing by 0. So another restriction is that m cannot equal 1. Then you go through the process. Well, I already took care of that factor, right? That's this one. And I already took care of this one, that's this one. I already took care of this one, that's this one. So there's only two restrictions, 0 and 1. All right? Now, once you find your least common denominator, once you find your restrictions, now remember, before I found that least common denominator, I had to factor, okay? And notice that I didn't do that in the other one. I didn't do it here because those were monomial factors. Here I notice that this is a binomial. So we need to look to see if we can factor this in a different way, either using a GCF, which I did, or if it's a difference of two squares or something like that, which it's not. But remember, you're factoring properties. Okay, now just like we did before, I'm going to multiply both sides by the least common denominator to clear those fractions. So in the process, you want this to end up being a factor 1, this to be a factor 1, and this to be a factor 1. That's the process. That's the idea you want to go through. Okay, so I'm going to go ahead, I'm going to kind of write this down here, so to get some room here. So I'm going to go ahead and rewrite this. The left-hand side, notice the left-hand side has two rational expressions, and leave it in factored form. Don't leave it like this, leave it in factored form. So I'm going to have 1 divided by m times m minus 1 plus 1 divided by m. Now this has to be multiplied by the least common denominator, which is m times m minus 1. Now what I do to the left, I do to the right. So the right-hand side, which is 5 divided by m minus 1, that has to also be multiplied by the LCD. Okay? So notice I multiply both sides by the least common denominator. Now we're going to go ahead and clear the grouping symbols, the parentheses, reduce if we can, and so forth. All right, so I'm going to get this. I'm going to get m times m minus 1 times the first fraction. Okay, just rewrite it like this, plus the LCD times the second fraction, m times m minus 1 times 1 divided by m, equal, I'm just going to go ahead and rewrite this over. All right, now the next step is to reduce. So I'm going to go ahead and reduce any common factor. So notice the m's divide out, the m minus 1's divide out. Over here, only the factors of m's divide out. Over here, m's divide out, the factors of m minus 1 divide out. And now I'm going to go ahead and rewrite this. 1 times 1 times 1 is 1, plus 1 times m minus 1 times 1 is m minus 1, equal 1 times 1 times 5 is 5, right? And so combining like terms, I get 1 and a negative 1, 0. So this is just m, and all I get is m equal 5. Now that's a proposed solution, right? So that's my proposed solution. So notice in the process, I went from a rational equation where I had variables in the denominator to a linear equation. See, that's the linear equation right here. That's linear. So I know that 5 is a solution to this linear, but is it a solution to the original equation to this rational equation. So you gotta make sure that this m equal 5 does not make your denominator 0. And all you gotta do is look at your restrictions. Is 5 a restriction? No, because the only restrictions are 0 and 1. So this proposed solution is a solution. So this proposed solution is a solution. So m equal 5 is a solution. And it's a solution because it's not one of these restrictions. It's a solution because if I were to substitute 5 into the original problem, the left side will equal the right side, and the denominator will never be 0. All right, that's number 2. And then let's look at number 3. So number 3, we have this. So let's see. Number 3, we have 1 equals n minus 2 divided by n minus 1 plus 3 divided by n squared plus 3n minus 4. All right, so again, I have this rational equation. I have fractions on both sides. I have 3 rational expressions. One's a rational expression. Even though you don't see any variables in it, it's still a rational expression. So I have 3 rational expressions. Now, before I find the least common denominator, I got to factor these denominators, and the only one I need to factor is this one, because the GCF here, n minus 1, is 1. There's nothing else you can do to factor this. Over here, let's go ahead and factor this. So when I factor this, that's going to be n plus 4 times n minus 1. All right, and so now the least common denominator must include every denominator that you see, every distinct factor, I should say, that you see. So in the first one, and I'm going to kind of visualize this here. See, that's 1 over 1, right? So my factor here is 1. So 1's going to be a factor of every least common denominator, so I'm not going to put it. Now, see, in n minus 1, I'm going to use that as a factor of my least common denominator, but notice I put that in parentheses. The next factor C is n minus 4, I have to use, n plus 4, I have to use it. The next factor C is n minus 1, I already have it. Okay, notice parentheses though. So remember, your least common denominator is a product of all the distinct factors that you see. Now, 1's in here because 1's a factor of every rational of every expression, every number, whether it's numerical or algebraic. Okay, now we got to find the restrictions. And all you really have to do is ask yourself this. So let's find the restrictions. So you got to look at all the denominators. Now, you see this right here? The denominator is a 1. It's never going to be 0. There's no variable there. So this denominator will never be 0. So there's no value of n that will make this 0 because it's always going to be 1. Now over here, I'm going to go ahead and write that factor out, n minus 1. You got to ask yourself, where is n minus 1 equal to 0? All of you know that 1 minus 1 is 0. So n equal 1, right? 1 minus 1, 0. So that's where n minus 1 is equal to 0 and n is 1. And so that's one of your restrictions. N cannot equal 1. Then the next one, n plus 4, do the same thing. Where is n plus 4 equal to 0? Well, n plus 4 is equal to 0 and n is equal to negative 4. So remember, you subtract 4 from both sides. And so notice that when n is negative 4, I want you to notice something. Negative 4 plus 4 is 0. Negative 4 and a negative 1 is negative 5. 0 times negative 5 is 0. And you get 3 divided by 0, which is undefined. All right, so n cannot be negative 4. And the next one's n minus 1, which we already took care of. That's 1. So this is 0 when n is 1. And you can check. 1 plus 1 is 5. 1 minus 1 is 0. 0 times 5 is 5. 3 divided by 5 is 0. That's undefined. So this rational expression has 2 restrictions. N cannot be 1 and n cannot be negative 4. All right, now we found the least common denominator. We found the restrictions. Now I'm going to multiply both sides by the least common denominator. All right, so I'm going to rewrite this. I'm going to write it as 1 equal n minus 2 divided by n minus 1 plus 3 divided by, now I'm going to use the factored form here, n plus 4 times n minus 1. Okay? Now we're going to multiply both sides by the least common denominator. So I'm going to multiply this side by the least common denominator, which is n minus 1 times n plus 4, right? And multiply this side. Now I don't have enough room here, so I'm going to go ahead and put that on this side. So n minus 1, n plus 4. All right. Now I'm going to get rid of this grouping symbol by distributing. So you can distribute the LCD here. So I get n minus 1 times n plus 4 times 1 is just n minus 1 times n plus 4 equal the LCD times this fraction. So n minus 1, n plus 4 times n minus 2 divided by n minus 1 plus, this plus is this, the LCD times this fraction, n minus 1, n plus 4 times 3 divided by n plus 4 times n minus 1. Okay? So all I did was I multiplied the LCD times this fraction. That's how I got the right-hand side. And this, the LCD times 1 is just the LCD. Now we're gonna go ahead and multiply these two binomials. So when I use the FOIL method, it's going to be n squared. The outer is a positive for n. The inner is a negative n. And the last is a negative 4 equal. Now notice over here, the n minus 1's divide out. Now be careful, you get 1 times n plus 4, which is n plus 4 in parentheses, times n minus 2 in parentheses. Okay, this times this. Notice the parentheses here, because this has to be multiplied by this. So you got to put parentheses here. Plus, and then over here, all of these factors divide out, and you're just left with 1 times 3, which is 3. Okay, now combining like terms over here, I get n squared plus 3n minus 4 equal, and then let's go ahead and use a FOIL method on these two binomials that are being multiplied together. So I get n squared, the outer is a negative 2n, the inner is a positive 4n, the last is positive 4 times negative 2 is a negative 8, and then plus 3. Combining like terms on the right-hand side, I get on the left side, I'm just going to write the left side over. And so I get n squared plus 2n, and then a negative 8 and a positive 3 is a negative 5. And then notice, now be careful, I went from a rational equation with variables in the denominator to an equation. Now this equation, you may say it was quadratic. Well, it's really, if you look at it, it's really a linear equation because the n squareds cancel out. So you really end up with a linear equation. But the other thing I want you to notice is that remember the whole purpose of multiplying the rational equation by the LCD is to get these denominators to be factors of 1s. And so notice n minus 1, I got a factor 1. N plus 4 times n minus 1, I got a factor 1. All right, so you clear the fractions. So notice that when I subtract n squared from both sides, I end up with a linear equation, 3n minus 4 equal 2n minus 5. Okay? Now let's go ahead and, so notice this is linear now. So we have a linear equation. So I'm going to bring all the variables to one side. So I'm going to subtract 2n from both sides. 3n minus 2n is n minus 4 equal. This is 0, and I get negative 5. Adding 4 to both sides, I get n to be a negative 5 and a positive 4 is a negative 1. Now remember, that's your proposed solution. That's a proposed solution. So that solution, n equal negative 1, is a solution to this linear equation. That definitely is true. Because you can check it. 3 times negative 1 is a negative 3. Negative 3 and a negative 4 is a negative 7. 2 times negative 1 is a negative 2. Negative 2 and a negative 5 is a negative 7. But you're solving the original. You're solving a rational equation. But notice that n equal, let's see, n equal negative 1, n equal negative 1 is not a restriction, right? Because this is a positive 1, this is a negative 4, so n equal negative 1 is actually going to be a solution. So if this was a positive 1, like we had here, and then you would say that this equation has no solution because your proposed solution is a restriction. All right, so n equal negative 1 is a solution. Is a solution because it is not a restriction. Okay, so that was number 3. So that is the process you're going to go through when solving rational equations by multiplying both sides by the least common denominator first. All right, so the old idea when solving rational equation and you multiply both sides by the least common denominator first is to get these denominators to be factors of 1s. So you're clearing your fractions. And so that's what you got to use. It's got to, whenever you're told those types of directions for solving rational equations, you have to use this process. Okay. All right. So that's the end of this lesson.